Hi, in this video lesson, I'll be talking about a preparation step for doing confidence interval and hypothesis testing questions. In a confidence interval question, you'd see that they talk about a researcher trying to estimate some value. And in this video, I'll be only doing mean and proportion. That narrows it down. A hypothesis testing question would involve a researcher trying to speculate something about the mean and the proportion. They may be claiming that the mean is 50 meters, or the proportion is more than 75%. Any of those would be a claim made by the researcher that makes your problem a hypothesis testing question. What you'll be learning in this video is to tell the difference between a sample that the researcher in the question has seen versus some population that they have not seen and they're just speculating about. A research question starts out always about a population. If you see that the researcher in the question is trying to estimate some value, or they speculate or hypothesize something about a certain value, that makes that value a population parameter, a population proportion of P, or a population mean of mu. But on the other hand, if you see in the question that the researcher has collected data on something, then that thing that the researcher has collected data on, that's a sample. That means all the information from that data collection consists of sample information. So if it's a proportion, then it's a sample proportion with the symbol P hat. If it's a mean, then it's a sample mean with a symbol of X bar. The questions that I'll be asking in this video lesson is for you to identify either the sample statistic or the parameter, and then write it down either as a symbol alone, if that's all the information that you receive, or if you receive more information, write it down as a full mathematical expression. For example, if the question says the researcher wants to estimate a proportion of some sort, then that's all the information you have. Just write down P, population proportion. And same thing if you see that the researcher is trying to estimate some sort of mean, then write down mu. But sometimes the questions will give you more information than that. If in the question you see that the researcher is speculating or hypothesizing or claiming that certain mean is 120, then you need to write down the whole expression that says mu for population mean equals to 120. And likewise, if the question shows that the researcher is speculating that certain proportion is more than 1/4, then you need to write down the whole expression P is greater than 1/4, or P is greater than 0.25, either way. On the other hand, if you read through the question and you realize that these are data that have been observed and collected by the researcher, then those are sample information, and they need sample symbols, such as sample mean X bar. So if it shows that it's not just about the speculation by the researcher, but the actually collected data that says mean is 120, then you have to write down X bar equals 120. If the researcher found certain proportion to be equal to 0.24 by collecting data, then it's P hat, not P, equals 0.24. If you know something about the sample size in the question, then write that down. The symbol for sample size is lowercase n equals 100. Or if the question reveals that the standard deviation of the observations is 5.831, that makes it a sample standard deviation, and you need to write down S equals 5.831. All right, first example. The Army wants to estimate the mean arm's length of 19-year-old females. The question is, what is the parameter or statistic at issue? Go ahead and try this. The Army wants to estimate the population mean arm's length of 19-year-old females. They haven't made any measurement yet, and what they need to know is of 19-year-old females, probably for the purpose of designing some sort of equipment for their service members. So the symbol for that will be mu. They're trying to estimate mu. That's all the information you have, so that's all you need to write down. Example 2. A survey of voters in the city shows that 61% opposes new sales tax. Same question, what is the parameter or statistic at issue? And matter of fact, it will be this same question throughout this video. Go ahead, try. The survey was already done on a sample, and that sample says 61% opposes. So it's a sample proportion. And we're told that the sample proportion is equal to 0.61, so you have to write down all of p hat equals 0.61. Next example. A university expects that more than 55% of next year applicants will be female. Go ahead, try this. The speculation is about next year's population. The university have not seen these people. So it's a speculation about next year's population. It needs a population symbol, and they're thinking that that P is gonna be more than 55%. So the claim is that P greater than 0.55. Next example. A biologist wants to estimate the height of an average giraffe by observing several dozens of them in Africa. The biologist has not done the observation yet. They want to estimate the mean height of a population of giraffes. That makes this a mean problem with population symbol, and that symbol is mu. Next example. Student wants to know the color distribution of the 5 colors of Skittle candies. After counting 2,000 candies, the student determined that there are 20.1% purple, 21.4% orange, 1.4% yellow, 18.1% red, and 19.0% green. For this one, there are 5 different colors, so you will need to use different subscript to distinguish them. You actually use the color name as subscript, so subscript purple, subscript orange, or you can number them, 1 for purple, 2 for orange. But if you're going to use numbers, you have to explicitly write down what does 1 stand for and what does 2 stand for, etc. All right, go ahead. These proportions were observed by the student out of the 2,000 candies. So all of this information is sample information. So it needs sample symbol of P hat. P hat, subscript purple, subscript orange, subscript yellow, subscript red, subscript green. There's one more piece of information that I didn't write down. That is lowercase n is equal to 2,000. Next example. A political consultant believes that the majority of voters will support the challenger against the current senator. Majority means more than 50%. A lot of people think that majority means 51%, but it isn't. It doesn't have to be 51%. As soon as it goes over 50%, it's majority. You need to only go to 50.00001 or something. So anything above 50% will do. The belief is about the voters, and they have not taken a survey of the voters. They've only speculating in that maybe the majority thinks like that. The symbol is P, and they're thinking that P is greater than 0.5. Next example. Students in last semester's statistics class scored an average of 64% on the final exam. This is actually a tricky question, so think about it a little hard. It's tricky because the 64% is not a percent of our sample, right? Our sample are the students, and we're not talking about 64% of students. We're talking about the score of 64 out of 100 if the test had been out of 100 points. We're looking at the average. Matter of fact, the word average appears in the question to help you out. So we're talking about a mean, and it's a sample mean because these are students that already took last semester's statistics class and someone already computed the mean of 64%. So the symbol is X bar is equal to 64%. Next example. An optometrist hires a marketing firm to estimate the proportion of people in the neighborhood who need corrective lenses and whether they have vision insurance. This is also a little tricky. There are two questions here, so use subscripts to distinguish them. So go ahead. Question is about the whole population. We need to use population symbols, and it's about proportions. So you have two proportions, the proportion of people needing corrective lenses and the proportion of people that have vision insurance. All right, some of you may be thinking, wait, about that second question with the vision insurance, is that proportion of the entire neighborhood or proportion of only people that need corrective lenses? The first one would be a regular proportion, and the second one would be like a conditional proportion, right? First, they have to need corrective lenses, and out of those people, what percent have vision insurance? Good point and good thinking if you're thinking that, but it doesn't matter. It will matter as we go out and collect data and do calculation. It will matter. But in terms of writing the symbol, we're just going to use P. There isn't a special symbol for a P that's conditional versus a P that's not conditional. Next example. A consumer protection agency checks cans of white tuna, albacore, and finds that they contain on average 0.32 parts per million, or ppm, of mercury. This is something the agency has observed, and therefore it's a sample statistic. So we're going to use sample symbols for this, and it is X bar equals 0.32. All right, now I'm going to give some more questions where both sample and population information appear in the same question. A typical statistics question would say both that the researcher is trying to estimate something or the researcher is making some claim, and then also that then the research goes out and collects sample data and brings back the information. So both information would be in the same question, so you need to separate them out. Whatever they're trying to estimate or speculate, that's population. And then also whatever it is that they observed and collected, that would be your sample information. Next example. A researcher wants to know what proportion of people in a certain county has been stopped by police for speeding. She asked 300 drivers, and 27 were stopped by the police for speeding at some point in the past 5 years. So you see here such an example that in the first sentence, there's something that the researcher wants to know. And then in the second sentence, there's something that the researcher did in terms of collecting data. Let's go ahead and do this one. Okay, what the researcher wants to estimate is the proportion in the whole population. So it's a population proportion P. What the researcher observed was out of 300 drivers, so that's a sample size, N equals 300. There was a proportion of 27 out of 300 that got stopped by police, so that's a sample proportion of P hat. Next question. A pharmaceutical company claims that its antibiotic tablet is 10 milligrams each. A lawyer checks 200 tablets and finds that the mean tablet weighs 10.2 milligrams with a standard deviation of 0.15 milligrams. The claim is about the population of all such antibiotic tablets. The checking done by the lawyer is on a sample of 200 of them. So the first sentence is about the population and the rest is about a sample. Therefore, For the claim, we write mu equals 10. And for the sample, we write n equals 200, x bar equals 10.2, and s, which is a symbol for sample standard deviation, equals 0.15. Next example. An engineer measures the hardness of 25 pieces of a certain type of iron and obtains a mean hardness of 172.5 and a standard deviation of 10.31. The engineer thinks that the average such piece of iron has a mean hardness of less than 170. The 25 pieces that the engineer measured, that makes it the engineer's sample. Put all of that in with sample symbols. Lowercase n equals 25, x bar is 172.5, and s is 10.31. The speculation by the engineer that the average piece has a mean hardness of less than 170, that's about the population. So that information is written with population symbol, mu less than 170. Next example. A doctor treats kids who have the cold and measures how long it takes to get better. 38 are given vitamin C and take on average 1.9 days to get better. 37 are given a placebo and take 1.7 days. The doctor thinks that in general, there's no difference between vitamin C and placebo in treating a cold. There's a typo there. In here, there are two groups of kids, right? So use different subscript. Again, you could use number 1 and 2 if you define what 1 is and what 2 is. Or you can use like full words, vitamin C or placebo. Or in this case, I would be using C for vitamin C and P for placebo, so I have to define it. All right, the variable that we're looking at is the number of days, right? How long it takes to get better from a cold. What the doctor did with the 38 kids on vitamin C and 37 kids on placebo, that's sample, 2 samples. There's a sample for the vitamin C with n subscript C is equal to 38, and a mean x bar of C is equal to 1.9. And then there's the placebo group where n sub p is 37 and x bar sub p is 1.7. And the doctor thinks that there's no difference between the vitamin C group and the placebo group. So that's a speculation about population. He's speculating about all the kids that take vitamin C's versus all the kids that take placebo. He's thinking that it's all the same. So you will need population symbols. And that will be that mu C is equal to mu sub P. I hope that helps. Press like and subscribe for more contents. And thanks for watching. Bye.